Today's lesson is on rational and irrational numbers, and then we're also going to talk a little bit about square roots. In the types of numbers that we work with primarily in this grade until you get to high school, we're going to be talking about real numbers. Real numbers are divided into two groups. We have rational numbers and irrational numbers. Typically, everything that you've worked with so far has been in the rational number realm. It involves numbers that are integers. So example, -4, 3, 0, 10. Could also be things that are like fractions, like 25/5, because that actually results in an integer. Okay, we're going to add one to this category in just a second here. We also have fractions. So you've seen fractions: 1/4, 2/3, -5/8. You can also have improper fractions as part of this group. Part of the rational numbers is also terminating and repeating decimals. Terminating decimals are ones that end 0.15. Repeating would be ones like 0.1313, and the 13 keeps repeating, or 0.3 repeating. Those are all ones that you've seen so far. We're going to add one to your integer column today, and it's the square root. And we're going to put the square root of 64 here. The reason I'm putting this in is when we talk about square roots, it'll make more sense because the square root of 64 is going to be 8. Over on the other side of the real numbers are things called irrational numbers. You've probably heard of one already, pi. It's 3.14 is typically what we round it down to, but it does keep going on forever and ever. Irrational numbers would also be decimals that have patterns. So for example, if you see this one, 0.10100100, and we would keep going and going and going. You could tell me that the next one is going to be a 1 followed by 4 zeros. The only problem is it doesn't actually terminate, and it doesn't technically repeat itself. It has a pattern to it. So irrational numbers includes things that have patterns. We're also going to put into the irrational numbers category the square root of 15. I'm going to explain that in a minute because the square root of 15 is going to end up being a decimal that doesn't repeat and doesn't actually terminate. So if I'm looking down here, this first one, notice that it has a pattern, so we're going to call this one irrational. This one, it looks like it terminates, it ends, so this is a rational. 1/4 is a fraction, it's a rational number. The square root of 51, we haven't quite talked about this, but I'm going to tell you it's irrational, and you're going to see why in just a minute. 0.45 with a bar, that's rational because it's repeating. 0.125, it ends, it's rational. 162%, we can make that into a decimal number, which can actually be represented as a fraction, so this is rational. 0.595995999 keeps going. This is irrational. It has a pattern, but it doesn't have any repetition. So what I want you to do is take a look at these three squares. This is talking about square roots. Find the area of the square. So you would do the 5 times the 5. The area here will be 25. In this one, the area would be 49. And in this one, your area would be 81. These numbers in here, the area of the squares, are what we're going to call perfect squares. In order for you to get the area, you multiplied the number by itself, which we call squaring. So we can use 2 and as an exponent on a number to show that we're squaring the number. So 2 squared really means 2 times 2, which is 4. In our 5 square up here, we did 5 squared, which really means 5 times 5, which gives us 25. These numbers are called perfect squares. If I asked you to go backwards and I told you the area of this square was 16, you would tell me that the sides are 4, because 4 times 4 would give you 16. What if I told you the area was 9? You would tell me 3 times 3. To find the side length, you figured out what number times itself would give you the area. This is actually called taking the square root of a number. We use this little symbol for the square root. Square root of 49, what number times itself gives you 49, is going to be 7. Okay? If I asked you to find the side length of a square whose area was 15, would you be able to do it? Not at this point, because there's no number times itself that actually gives you 15. So because of that, 15 still has a square root. There still is a side length here. It's just not one that we can easily figure out. So what we can do is we can actually estimate square roots that don't work out perfectly. So we have some perfect squares listed down the side here. 1 squared 1, 2 squared 4, and so on and so forth. So if we look at this, we want to estimate the square root of 45. The square root of 45 is going to fall right in here because it falls between 36 and 49. So it's going to be between the square root of 36 and the square root of 49. So since the square root of 36 is 6 and the square root of 49 is 7, we know that the square root of 45 is going to actually be equal to a number somewhere between 6 and 7. We can take it a step further and actually try and estimate what the 10th place would be by looking at how close is 45 to 36 or 49. It's not quite in between. It is definitely closer to 49, so it would be in the higher sixes. So maybe something like 6.7 could be a good estimate. Your calculator can actually do square roots for you. We're just going to be using them to kind of check our estimates right now and see how we did. Square root button is right here. You would type in the square root of 45, hit equals, and you'll notice it was 6.708. So our estimate of 6.7 was pretty close. On the next side, the square root of 68. 68 is going to fall in between here with 64 and 81. So it's between the square root of 64 and the square root of 81. The square root of 64 is 8, and the square root of 81 is 9. We know that this would be somewhere between 8 and 9. Hopefully you're looking at 68 and being like, ooh, that's way closer to 8. So we would go with something like 8.1 or maybe 8.2. If we check the square root of 68, we end up with 8.24. The next one is 102. That's going to fall between 100 and 121. Square root of 100 is 10, and the square root of 121 is 11, so this is going to be somewhere between 10 and 11. Again, it's very close to the 100, so I would say an estimate is probably going to be close to 10.1. Check ourselves. The square root of 102 is 10.099, which would round to 10.1. So the next part has us use our knowledge of square roots to order these numbers from greatest to least. So we're going to start off. The square root of 16 is 4, and the square root of 5 is going to be between the square root of 4 and the square root of 9. This is going to be somewhere between 2 and 3, but closer to 2, so maybe like 2.1-ish. Over here, 15/8 is going to be about 2, and 3.6, we can just leave. 27ths is going to be about 3, but it's going to be a little bit under. And this is going to actually be a little bit under 2 as well, so I kind of make some marks on here. Greatest number out of these is clearly the square root of 16 at 4. The next one, I would have to say 3.6 is going to be the largest. The next one would be my number right under 3, which would be 27ths. And then this one we said would be above 2, and this one would be below 2. So let's go with this one since it's above 2 next, and finish it out with 15/8 then as our last one, because that's below 2, it would be the smallest of these. In this one, it says which point on the number line below is closest to the value of the square root of 152. Square root of 144 is going to give us 12, and the square root of 169 is going to give us 13. 152 would be right in between them. So if we're looking at 12 to 13, we're either J or K. Is 152 closer to 144 or closer to 169? 144, so it would be closer to 12. J would be your answer. In this one, it says if the point P represents the square root of x, which point is closest to the value of x? So this is telling me that P is the square root of x. So the square root of some number is about, we're between 0 and 5, so about halfway between. So we kind of have to work our way backwards here. If we were to go ahead and square 2, we would get 4. If we were to square 3, we would get 9. Now why did I do that? Because 2.5 is between 2 and 3. So we know that our answer is going to be somewhere between 4 and 9. Is 2.5 closer to that or that? It's kind of right in the middle. So if I'm looking, 4 would be right here, but 9 would be right here. The best one is going to be C because it's kind of right there in the middle of those two numbers. Which point is close to the location of negative square root of 10? Don't worry about the negative part right now, but that does allow us to cross off D because that's not even going to be an option because there's a negative out front. The square root of 10 would be between the square root of 9 and the square root of 16. This would be 3 and this would be 4. We're closer here, so we're going to be closer to negative 3. If you're looking at this, are we going to be below negative 3? No. Are we going to be above negative 3 and by 5? No. Our answer here is going to be B. Final question goes back to additive inverses. We have negative 4. What can we add to it? That's going to give us 0. Negative 4 plus a positive 4 would give us 0 because they're inverses. So that would be point D.